We should be familiar now with writing the sine, cosine, tangent trig ratios. There are actually three more. So along with sine, there is also something called the cosecant. And the cosecant function of theta is if you take the sine and flip it over, so it's actually h over o. A lot of books will also write it like this, 1 over sine of theta. So just know that if you have the sine or the cosecant, to get the other you just flip the fraction. Same with cosine. You can also get secant of theta, which is just the flip of the cosine function. So that guy's secant, that guy's cosecant. The last one here is cotangent of theta, which would be a over o. Cotangent. And again, secant is 1 over cosine of theta, and often cotangent is 1 over tangent of theta. Okay, so where will you see this? For example, sometimes they'll give you a triangle. They'll put theta in the corner. They'll put 5, 12, and 13. And then they'll say find all 6 trig ratios. Okay, which by the way, they don't always have to give you all 3 sides of the right triangle. They might give you the 5 and 12, and you have to use Pythagorean theorem to find the hypotenuse. Okay, so to find all 6 trig ratios, I normally start with my original ones. Sine here is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And then tangent is going to be opposite over adjacent. Now to find my partners here, cosecant of theta is if I take the sine and flip it over. So that would be 13 over 12. Secant of theta is this flipped, which would be 12 over 5. And then cotangent of theta would be 5 over 12. And I realize now that I accidentally wrote the wrong hypotenuse here. So for cosine, it needs to be 5 over 13, and secant should be 13 over 5. So that's just one way to get your trig ratios. They might also, in another example, give you a different kind of setup. They might say something like, if sine of theta is 3/7, find all 6 trig functions. Okay, so what are they giving us? They're giving us, right here, opposite over hypotenuse. So I'm going to draw a triangle here. Opposite of theta, we can just write 3 here. The hypotenuse is 7. And so using this triangle, we can actually take this and find our adjacent. We just have to do x squared plus 3 squared equals 7 squared. We're doing Pythagorean theorem. Okay, so x squared equals 40. X is really the square root of 40. And to simplify square root of 40, that eventually comes out to be 2 root 10. Now the idea is that you could break this up into root 4 times root 10, and then square root of 4 gives you 2. So that's simplifying a radical. So I'll write here 2 root 10. Alright, to do sine of theta, we already have it. And then cosecant is just going to be the flip, so we could write 7/3. Cosine is going to be now the adjacent over hypotenuse. So this will be 2 root 10 all over 7. And then I guess we should do this next. We'll look at secant. Secant is paired with cosine, and that's just going to be the flip of this. So it would be 7 over 2 root 10. Now let's finish up here. Tangent is going to be 3 all over 2 root 10, and then cotangent is just going to be 2 root 10 all over 3. So the trickier part is going to be setting up your reference, it's called a reference triangle, and then figuring out all the ratios is not that hard. Now, one thing that textbooks might do, though, is require rationalizing the denominator. It's not polite to leave a square root in the denominator, so if you multiply the top and the bottom by root 10 here, this will rationalize for you. On top, you're going to have 7 root 10. And on bottom, root 10 times root 10 is just 10. So 10 times 2 is 20. Now, this is totally the same as what we had before. It's just rationalized. Same with down here with the tangent. If we multiply by root 10 all over root 10, the revised answer is going to be 3 root 10 all over 20. But this is only necessary when you have a radical on the bottom, and some books don't even expect you to do this. And the point is that if they give you something like a ratio, could you draw the triangle and set up all the trig functions?